Ever loaded a shapefile in QGIS and your layers just refuse to line up? Don't worry. The problem isn't your data. It's your coordinate reference system, or CRS. And today, you're finally going to understand it the easy way. CRS decides how your map understands the Earth, whether your coordinates represent degrees or meters. If you choose the wrong CRS, and your spatial analysis becomes unreliable. So in today's tutorial, we'll learn the difference between geographic and projected CRS with EPSG codes, how to reproject layers, and why projections actually matter in our maps. There are two main types of CRS. Geographic CRS that represents the Earth as a sphere using latitude and longitude in degrees. Example is WGS 84, which we have displayed right here. It's used globally, especially in GPS and web maps. And a projected CRS flattens a curved surface into a plane for measurements in meters. For example, UTM zones or local systems like EPSG 3857, Web Mercator. The key difference is that geographic CRS is for location, and projected CRS is for measurements and analysis. Every CRS has a unique identifier called an EPSG code. For example, this is displayed here as EPSG 4326, which is WGS 84, and you can always find or change these codes from the bottom right CRS icon in the QGIS. Sometimes, all layers are in different coordinate systems and don't align. So to fix this, you can click on this icon over here and select the specific CRS that you want to display it in. Right now, we are showing it in 4326. So over here, we are showing a shapefile of Pakistan overlaid on a base map by OSM standard. And this is displayed in EPSG 4326, not WGS 84. Now, notice as we change the coordinate system to UTM 3857, how the projection changes. And you can see now our map is a bit distorted. And we can choose any of the EPSG codes or any of the projection systems are present over here in QGIS. QGIS also has something called On-The-Fly CRS transformation. It allows layers with different CRS to appear correctly together in the map canvas to begin with. It temporarily converts them so they can align visually. You can enable or disable them using the CRS status button at the bottom right of QGIS. So why does this matter? Because the choice of projection affects the distance, area, and accuracy. So if you measure using a geographic coordinate system, it will show you the accurate location of the place. But if you use a projected CRS like UTM, your units are in meters, perfect for measuring and mapping. And it is important to always choose a projection suited for our region and our purpose. Let's review what we learned. Geographic CRS. Global scale projected CRS gives accurate measurements. EPSG codes uniquely identify each CRS. On-the-fly transformation aligns. Temporarily reprojection permanently converts a layers. If this helped clarify CRS for you, don't forget to subscribe. And make sure to check out the full playlist for more beginner-friendly QGIS tutorials.